Okay, so this is LeetCode problem number 80, and this is the variation of last problem that you already solved. Okay, so the problem is nothing but we just need to remove the duplicates from sorted array, and this is true. And earlier we solved remove the duplicates from sorted array 1. Okay, yeah, the statement is nothing but we are given an integer array and that is sorted in non-decreasing order, and need to remove some duplicates in place. That means we are not allowed to take any extra space such that each unique element appear at most twice. Okay, and the relative order must be same. Okay, okay, and we need to return a after replacing the final result in the first k slot of the nums. That means we just need to place all that k elements to the first slot of the array, and we need to return the length, and k is nothing but the length, and we need to do this in constant space. Okay, so basically you will able to understand with this example. Okay, so you can see this is the array and that is nothing but sorted from left to right, and you can see it also contain lots of duplicates. So as we mentioned that we can have at most two duplicates, so you can see we can have 0 2 times, and 1 2 times. You can see 1 is coming 4 times, right? But at most we are allowed to keep at most 2 times. That's why 1 is 2 times, then 2 will 1 time, so it will same as it is, and 3 is 2 times, so we'll be taking this also. And for the rest of the part we don't need to bother about, right? And you can see finally the length will be nothing but 7, so we need to return 7. Okay, and the important thing is you can see the relative order also same. Okay, that's the thing. Now let's analyze this example, okay, to find the approach. So you can also able to understand that we just also need to use the two pointer approach, okay, to achieve the achieve a solution, okay, in constant space. Okay, so we need to use the two pointer approach, but yeah, the approach, although the approach will be similar to the last problem, but we just need to apply a little bit trick for to solve this problem, right? Now let's discuss this. Okay, so you can see this is second example, and we are going to analyze this example to find the solution. Okay, and yeah, obviously we are gonna we are gonna use the two pointer approach, but here the trick will be taking a variable counter. Okay, so we just need to take a variable counter so that we can track, we can maintain the frequency of the current element, because we just need to maintain that the duplicate at max can have two sides. Okay, that's why we just need to take a counter to maintain that. Okay, and that is the only trick for this problem. Okay, and all the approach will be very similar to the last approach, to the last problem. Okay, so let's analyze the problem, analyze this approach. Okay, so what I need to do, we will have two pointer. Okay, first point will start from here, so I'll start from 0 and J will start from 1. Okay, and we'll also need to have a counter, and initially the counter value will be nothing but 1. So you can ask me why 1 not 0. Okay, so right now I is pointing to the 0 value, so we are considering that the frequency of 0 is nothing but 1 right now. Okay, so frequency of the very first element is 1 right now, that is we are considering right now. Okay, so that's why the value is 0. Okay, so let's analyze the thing. So basically we need to compare these two value, and there will be two cases. These two value can be equal, or these two value can be not equal. Okay, so these are the two cases we just need to handle for this. Okay, so basically what I need to do, every time we need to check whether these two value are equal or different. Okay, if both the value are equal, then you also need to consider that whether the counter value is less than 2 or not. Okay, because we need to have at most two, we need to have at most two duplicates. That's why you also need to consider that the counter value is less than 2 or not. Okay, now let's analyze this. Okay, right now both the value are equal, so right now we need to check, also need to check the counter value. So you can see the counter value is less than 2. Okay, counter value is less than 2. So in that case what I need to do, first of all we need to increase the value. Okay, first of all we need to increase the value of counter by 1, so this will be 1. Okay, and 1 plus 1, this will be right now 2. And what I need to do, we need to increase the I pointer by 1 place, and we need to put the value of say at the ith position. So right now you can see both are at the same position, so we don't need to basically put the value. Okay, so and as usual we know that z will increase by one place every time. So right now z is here and I is here. Okay, now again we need to check that if the both value are different or equal. So you can see the both the value are different. So what I need to do in this case, first of all we need to initialize, we need to initialize the c pointer by 1. Okay, so now you can ask why we need to initialize the c pointer by 1. Okay, so right now we are encounter a value that is different, so we are getting a new value, right? We are getting a new value. So for this new value the current frequency is nothing but 1. That's why we are initializing the value of c, okay, with 1. That as simple as that. Okay, and yeah, and again we also know that if both the value are different, then first of all we need to increase the I pointer by 1. So I will be here, and then we need to put the z pointer value at the position of I. Okay, so that is the thing. Yeah, that is every time we need to place the z pointer by 1 place. So right now z is here. So now again we need to check whether these two values are same or different. So you can see both the value are same. So what I need to do, we need to increase the point see counter variable by 1, and we also we also increase the value of I pointer, and we need to put the value of z pointer at the position of I. So both are same index, so we don't need to bother about. And again z will be here. Now again we need to check whether these two are equal or not. So you can see both are equal, and you also need to check whether the value of counter is less than 2 or not. So you can see the counter value is not less than 2, it's equal to. So what do you need to do, we don't need to increase the I pointer by 1 place. We only need to uh, increase the z pointer by 1 place. Okay, in this case. Okay, you just need to keep in mind that if the counter, okay, the counter value is not less than 2. Okay, in that case you only need to increase the z pointer. Okay, and I'll be at its own place. Okay, so now let's again check these two values. So you can see both the value are equal, but you can see the counter value is not less than 2. So we'll again only increase the z pointer by 1. So right now if you check, you can see both are different. So we are at this condition. So in this condition what do you need to do, first of all we need to initialize the counter value with 1. Okay, initialize counter value with 1, then we need to increase the value of I by 1 place. Then we need to put the value of z at the position of I. So right now you can see that both the position are different, so we just need to put that value. So this will be nothing but 2. Okay, okay, and again we just need to increase the j pointer by 1 place. So you can see again both are different. So what I need to do, we need to initialize the counter by 1. Okay, and we need to increase the j by 1, and then need to put that z value, not z actually, I by 1. I need to put the z pointer value at the I position. So this will be 3. Okay, and yeah, as usual j will increase by 1. Now again both the value are equal. Okay, so at this case what I need to do, we need to check whether the counter value is less than 2 or not. So you can see the value is 1. So what I need to do, we need to add increase by 1, then we need to increase the z pointer also, I pointer also, and we need to you know put the z value at the ith position. So it will be 3. Okay, and again the z will increase by 1, and right now you can see z is out of index for this array. And we can say that we iterated all the elements and we completed all the tasks that we need to do. Okay, and right now we can see that we got the result actually, 2 times 0, 2 times 1, then 2, then double 3. Okay, and we just need to return the uh, ith index plus 1 as usual, that we already did in the last problem, right? Why I plus 1? Because you can see right now I is pointing to this element, and if overall length will be nothing but I plus 1, because this is a 0 based index, right? That is as simple as that. So if I erase everything, you will also able to know this is the result that you already get. Okay, now let's jump into the code section. Now let's code the approach. So first of all what I need to do, we need to keep two pointer, one will I that will start from 0, and another will z that will start from 1. Okay, and you also need to keep a counter. Okay, counter and that value will need to initialize with 1. I will already explain why. Then we need to use the loop, okay, and loop will be very simple until z pointer will less than the length, okay, so that is nothing but nums dot length, okay, and as simple as that. So here we need to check whether, first of all we need to check both the value are different or equal, okay. So for that case we need to check if nums of I pointer value is equal to nums of j pointer value or not, okay. If both are equal, then you also need to check whether the pointer, whether the counter value is less than 2 or not, right? So counter value is less than 2 or not, because you already said that we only have at most 2 times, right? So that's why you also need to consider this counter variable, and this is the only trick for this problem, okay. Yeah, that is the thing. And if this satisfies, then what we need to do, we need to increase the counter, okay, it will be counter by 1. And what we need to, again we need to increase the I pointer by 1 position, and we need to put the z pointer value to the I position. So nums of I will be nothing but nums of, sorry my bad, nums of j, okay, and as simple as that. And this is the first condition. And second, what is the second condition, okay? Else our second condition will be what? Our second condition will be if both the value are different, right? So if nums of I is different, that means not equals nums of j pointer value, then what we need to do in this step, in this step we need to initialize the counter value to 1. Why 1? Because we encounter with a new value, and for the new value the frequency is nothing but 1. That's why we are initializing the counter value as 1, right? And then we need to again increase the I pointer by 1, and we need to initialize the I value of I pointer with the value of z pointer, right? So nums of z, okay, as simple as that, okay. And that is the thing, and we already know that every time whether these two conditions satisfy or not, every time we need to increase the z pointer by 1 place, right? As simple as that, okay. And finally what I need to do when we'll out of this loop, okay, we iterate all the number, then simply we need to return the I plus 1, okay, because kindly this will have the last index of our result of our elements, and plus 1 because this is nothing but a zero base index, and that's it. So already explained in that section, okay. So this is very simple code you can see, and obviously you can see that these two lines are very similar. These two lines are equal for these two conditions. So yeah, you can also wrap these two condition into one step, one condition, okay. And yeah, I'm just leaving this part on you, okay. So let's run this to check whether we have some error or not, okay. Okay, so you can see this working very well. Now let's submit to check it's getting submitted or not, okay. So you can see it gets submitted. So yeah, that's it. And if we you know talk about the time complexity, then obviously it is linear time complexity because we are using two-pointer approach, and we are also not taking any extra space. So yeah, so the space is also big of 1. Yeah, that's it.